All right, today we're going to look at examples of what happens when you're multiplying integers. We're going to start by just taking 2 times 5, which would be a positive times a positive, which for us means we are making 2 groups of 5. So one group of 5 and another group of 5 gives us a total of 10. On our next one, we're doing the same type of idea, but now we're taking a positive times a negative, which we could look at as 2 groups of negative 5. So once again, I'm going to draw 2 groups, but this time inside each group, I'm counting by negative 5. So negative 5 and negative 5 would give us a value of negative 10. So what happens if we switch it around, right? What if we switched it so that the negative was actually with the first number instead of the second number? The way we look at this is this becomes the opposite of 2 groups of 5. So we would draw our 2 groups of 5, but then we apply this like opposite switch, or if you want to think of like flipping your coins over, and it becomes 2 negative 5s. So when we have the opposite of 2 groups of 5, we end up with an answer of negative 10. So thinking about that, if we have the opposite of 2 groups of negative 5, I start with my 2 groups of negative 5. We flip those over with that opposite switch again, and they turn into 2 groups of positive 5, which gives us a value of positive 10. Hopefully, kind of looking through that, you noticed a pattern that, for example, the middle 2 problems both gave us answers that ended up as a negative 10, but that our first problem and our bottom problem both ended up as answers of positive 10. And if we ask ourselves what do they have in common, hopefully you notice that these 2 problems each have a positive and a negative value being multiplied, whereas these 2 problems each have the same sign. So we have a positive and a negative times a negative. This relates to dividing because, as we know, dividing and multiplying are kind of like sibling operations, meaning they work similarly. So if we think of taking $15 and that's split into 5 equal groups, we could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? So we have these 15, but then we're going to split them up into their groups in 5 at a time, right? Or into 5 groups. And we know that 15 split into 5 groups would mean that there are 3 in each group. In this case, it would be a positive 3. So 15 split into 5 groups gives us an answer of positive 3 in each group. So what happens if we take negative 15 and split it into 5 groups? Well, it's the same type of idea, but this time, instead of it being a positive 3 in each group, it becomes a negative 3. Which means when we take negative 15 split into 5 groups, our answer ends up being negative 3 in each group. So now I want you to make a prediction based on what we did on the top with multiplying. So once again, if we looked here, our 15 divided by 5 was a positive. but then our negative 15 divided by 5 was a negative. So what do you think that 15 divided by negative 5 would be if it follows the same patterns as multiplying? Hopefully you looked at it and you figured out that since it's one sign of each, a positive and a negative, that this one will also end up being negative 3. And we can kind of look at it as 15 put into 5 groups, but then applying that opposite switch again. So it ends up being a negative 3. So what happens when we have negative 15 split into the opposite of 5 groups? Well, same thing. We're going to kind of take that negative 15 that was split into the 5 groups, but apply the opposite. So this time it ends up as a positive 3. So we see that same pattern that we saw when we were multiplying integers. So what does this mean for us? What do we need to remember? And we're going to put a little note up here that this is when we are multiplying two numbers. And we're going to talk about why that is. But when we're multiplying two numbers, so for example, 15 times 3 or negative 15 times 3, and the signs are the same, my answer is always going to be a positive value.
That's cool.
But when the signs are different between those two numbers, then the answer is going to be a negative
You have 1 more hour.
value.
You have 1 more hour. Till it's the party time.
All right, so this was when we were multiplying two numbers. Now I want to give you an extra problem for you to think about. What if I was multiplying 3 numbers? What if I was multiplying negative 3 times negative 2 times negative 4? I want you to pause the video and think about, do you think that answer is going to be a positive or a negative?
Negative.
All right. So some of you may think that it's going to be a positive because all the signs are the same, but the answer is actually negative. And here's why. Because when we multiply, even though we're multiplying 3 numbers, we're only multiplying 2 at a time. So in this case, we would take our negative 3 and multiply it by our negative 2. And since that's a negative times a negative, it's going to give us a positive 6. And then we have to bring down that negative 4. And now, because we have 6 times positive 6 times a negative 4, now our final answer would be a negative 24. And so what you'll see is that there's a pattern that if we have an even number of negative signs, our answer is positive. But if there's an odd number of negative signs, it's going to be negative. So if we had a negative times a negative, that's going to equal a positive. But if we had a negative times a negative times a negative, that's going to be a negative. And then a negative times a negative times a negative times a negative is going to be back to positive. So it goes every other, because every 2 negatives that get grouped together, so these 2 get grouped together and make a positive. These 2 get grouped together and make a positive, but then there's a negative left over. These 2 get grouped together, and then these 2 get grouped together to make a positive, and there's no negatives left over. So when there's an even number of negatives, it's a positive answer. When it's an odd number of negatives, then it's a negative answer.